Everyone, welcome back from the break. Welcome back, everyone. Welcome back from the break. I hope you're all suitably caffeinated. And for the first talk of the mid-morning session, we've got Ben Nuttall, who's going to talk to us about physical programming paradigms and IoT. So please join me in welcoming Ben.
Morning, everyone. So I'm going to be talking about programming paradigms for physical computing and IoT. A lot of this is centered around the Raspberry Pi, but it's about the principles that could be applied in any kind of environment, the way you're dealing with devices and actually the behavior of systems, which could be things around the house or even sort of industrial systems for control and things like that. I hope you get the idea. So looking at the Raspberry Pi, you have a set of GPIO pins that allow you to connect to the real world. So this is a really easy way to get involved in this kind of world of hacking with devices. And the I/O pins allow you to control anything from simple components right up to sort of more complex things that have, say, microcontrollers attached and things like that. Now, in the early days of Raspberry Pi, the APIs that you would use, you could use something like Python, but the APIs that were around were kind of copied from the style of programming you would use with Arduino, which is C code. And you'd have a lot of things where you're talking about the pins, where you're sort of saying, turn this pin on, turn this pin low. So you've got different pin states, and you're not really talking about the devices that you're talking about. You're talking about what the state of the pins is doing. So myself and Dave Jones put together a Zero boilerplate API based on the ideas and principles of Pygame Zero, which if you were at the CoderDojo last night, we were playing with. So GPIO Zero introduces the concept of device classes. So here's the simplest example, LED, which is just a simple light. And with an LED, you can turn it on, you can turn it off, you can toggle its state, and you can even blink it. So you don't have loops where you're saying, turn this pin high, turn this pin low, sleep in between. That's built into the library. So and it has a kind of guessable names for the and sensible common default values for functions. And it introduces a smooth learning curve with a really simple way to get started. Zero boilerplate, so it's the idea is that you have to write as little code as possible to do basic things, but it doesn't end there. So it's that learning curve will take you all the way up to much more complex projects, which I hope to show you. It's also very extendable, so you can add on things and you can use the concepts involved and implement the same kind of behaviors in your own libraries and your own projects. And it has a multi-paradigm approach, which I'm going to explain now. So imagine a really simple example. You have an LED and a button, and you want the buttons to control the LED. So when I press the button, the LED should come on. Now, you can start with a really simple code like this, where you have a while loop, and you're asking the question, is the button pressed? And you're deciding whether you want to turn it on or turn it off. And you're just running around that loop really fast, just constantly checking the state. And that's fine, it works, and it's a really good way to get started. Another way you can do it, where you're not quite, you've still got a while loop, but you're not going around it as fast. You can wait until the button's been pressed, so there's a blocking element. It's still procedural code, it's still really simple to follow. But then you're waiting for it to be pressed before you run that LED on, and then waiting for it to be released before you turn the LED off. Then you've got event-driven callback approach. So you assign an action to the when pressed property and the when released, and you're doing exactly the same thing. You're running LED on and LED off, but they're firing in the background with background threads, so that you freed up your program. You're not in a while loop, stuck in a while loop anymore. You can write some other code that can do something else, but you've still got those events set up. So as many times as you press that button, you'll be firing those events. And then there's a fourth approach, which is more declarative, and you've reduced the amount of code down from that many lines to just one line defining how the LED should behave. So you have led.source equals button.values. Now let me explain how that came about. So every device in GPIO Zero has a value property, and you can read whether it's an input device or an output device. Now, LED, I showed you before, a normal LED is just on or off. A PWM LED, which is the same component, but you're just programming it in a different way, it allows you to set the brightness, anything from 0 to 1. So if you read a PWM LED's value, you'd see it initially at 0. And if you turn it on, you see its value is now 1. Now you can set it to, you can set its value without running the on function, the on or off methods, but you can set its value to any float between 0 and 1. And similarly, you can read an input device's value. So if you're reading a button, you'd see a true or a false. Now, a potentiometer connected to an analog digital converter, so this is the name of the chip, the MCP3008. A potentiometer is a rotary dial that you can read its value. And again, they're all on these on the same sort of scale. So you're reading it as a value 0 to 1. So you can actually, you might want to be able to send the potentiometer value directly into the LED. So if you set its value like this, led.value equals pot.value, you set it once and it'll be matching at that current moment in time. So what you end up doing is writing a while loop where you're constantly setting the value to match the value of the LED to match the potentiometer, so that when you dial up and down the potentiometer, your LED brightness is going up and down. But again, we're stuck in a while loop, and you can't do something else without backgrounding that. So we added something called, as well as value, you also have dot values. Dot values is simply a generator constantly yielding the current value. And this allows you to loop over that, iterate over that infinitely, and yield its current value. And so what we did on the other side, if you look at an output device, any device that can have its value set also has a dot source. That will take in any iterator, including an infinite generator, and continuously iterate over it, setting its current value to whatever comes in. So you can pair these two up like this by setting the source of one thing to of one device to the values of another. So pairing up an LED and a button means the button is constantly sending its values into the LED, and then you end up with code like this. Or in the example I just showed, you've got a potentiometer controlling a PWM LED. And as well as just being able to directly pair up two devices, you can also process the value in between. So you can have your own function that does something to that value before it gets to the next object, the next device. So for instance, if you had an LED and a button, if you wanted the opposite behavior, where you want the pressing the button to turn off the LED, but it should be on when it's not pressed, you can negate that value in between. And we actually provide a bunch of what we call source tools within the library for common things like that. So you can easily negate the values as they're going into the LED by setting the source to the negated button values. Now, we also have lots of other, these are all the single source conversions. So there's things like Booleanized, clamped, inverted, negated, queued, smooth, scales, things like that. There's all sorts of things that you can do. You can also combine multiple values. So if you have two devices and you want to do something to both of those values and zip them up and do something to them and then pass that value into the output device. For example, two buttons controlling an LED. So the LED should be on when both buttons are pressed. You can effectively AND the value pair and pass that into the LED. And that's really simple as well. So there's all values is like so it's like the AND, but for any number of values passed in. That could be any number of buttons there. And you can do lots of other things like averaging, multiplying. You can also chain combine values together. So if you have a motion sensor, that's just there is motion or there isn't motion. It's a Boolean. You get a Boolean value. But something like a light sensor is not just is it light, is it dark. It's like a potentiometer. It's a float value. So you would have a threshold for what you would consider light or dark. So you would just use the Booleanized tool to give yourself a Boolean as whether it is in a particular range, either at the light end or the dark end. But then once you've got a Boolean, you can then AND it with the motion sensor. So if I want my light to come on when it's dark and there's motion, a bit like a garden light, and then you have something like this. So this is a prototype using actual GPIO Zero components. So you just have a, on the desk on a breadboard, you'd have an LED, a light sensor, and a motion sensor. And you use this diagram. That's what it looks like in the code, so this bottom line here. So you've got the all values of the Booleanized light values between 0 and 0.1, which means it's dark, and also with the paired with the motion values. But if you wanted to actually do this, the idea is that you could use these exact same concepts in another library. If you had, it doesn't matter what the underlying code looks like that actually controls your garden light or your light sensor or your motion sensor. If those implementations were provided by another library, they could provide the same API and allowed you to write the same code as your prototype, to actually easily move from a prototype to a real project using exactly the same thing. What you can also do is, instead of always defining your behavior in that declarative style, you can mix up your paradigms as well. So this one you could consider quite complicated in that you've got to Booleanize one of them before you can set your source that way. Another simpler way might be, depending on your point of view, is to bring it back into the procedural approach, but also mix it with the setting the source to something really simple. So you have, like you have wait for press with a button, you have wait for dark. So whenever it hits the darkness threshold, then continue, then set the source to be the motion value. So it doesn't matter what the exact light level is, but you've now declared it as in a state of darkness. And then your garden light should come on when there's motion, now that we're in dark, so you don't have to combine the two. But then as soon as light comes back around, you set the source to nothing, so you null that out and waits for it to be dark again, so the motion sensor isn't being read at that point. And you can do lots of this using different paradigms, and you might sort of have some things which are very state dependent, so you're sort of moving through a system and you're waiting for something to happen, and then there's a new set of behaviors for your devices, and it's really handy to be able to have these multiple paradigms that you can do this with. There's also artificial devices, so you could just write your own function, or even something like a generator expression, or even a list, and send those values into a device, so something like an LED. So if you had a particular pattern, let's say you created a Morse code reader or something like that, you could send those flashes into the LED in a sequence rather than it coming from some other device. We provide some artificial sources as part of the source tools. So alternating values is the same as writing led.blink, where it's constantly flashing. And you can also time how quickly these are iterated over by setting the source delay property. So you can slow down how quickly it's getting those values. If you had something like a motor, so I've talked a lot about, so you've got booleans and floats 0 to 1. Some devices like a motor actually has 0 would be stopped, 1 would be full speed forward, and -1 would be full speed backward. So if you passed in, and the same goes for actually not a relay, a servo, so moving a robotic sort of servo arm, goes -1 to 1. You can pass in something like sine values or cos values and have it sweep in that kind of sense. And the same for a motor, you can have it rising up and down. And there's lots of other ones that you could write yourself. These are just common artificial sources. Here's an example of, we also provide what we call sort of external devices, which are, they have all the same API behavior as a GPIO Zero GPIO object, but they're nothing to do with the GPIO pins. So time of day is one, so it's just a concept. It's a bit like a button in a way. It has the same API in that a button is either pressed or it's not pressed. A time of day object is active between a particular time and another time. So declaring a time of day object called daytime that's active between 9 a.m. and 6 p.m. just means whenever you read its value, it's either true or false, whether it's in or out of that time period. So if you wanted to, so this is my tortoise's heat lamp. I want the light to be on just during those daytime hours. So I have a lamp, an actual heat lamp that's mains voltage, and it's connected to something called an Energenie socket, which is a way of you remotely controlling and safely remotely controlling a mains voltage power supply. You just plug it into the wall and plug your device into it, and from the Pi you can actually send it a signal to do that. That's built into GPIO Zero. And it's also really easy to write your own kind of custom external devices as well, either by defining the class and having the same properties, or just having a function that sends its values over. So an example of another library, another Python library that uses the same API style as GPIO Zero is one that's written by my colleague Martin O'Hanlon called Blue Dot. So the idea is you have an app on your Android phone, and it comes out with a big blue dot on the screen, and you pair it with Bluetooth over with your Pi, and you can receive button presses from it remotely. So you could control a device like an LED or like a robot or something like that using this big blue dot. So simple example again, just replacing these are all exactly the same examples as the ones I started with an LED and a button. You have an LED and you have your blue dot. You have the blue dot is pressed, so that's the same as is the button pressed. So you can use the same idea there, procedural polling, procedural blocking. So wait for the blue dot to be pressed. You have when pressed, so when the button is pressed, trigger this action, and then of course source and values. So iterating over whether the blue dot is pressed. Now the blue dot doesn't just have the concept of being pressed or not, it also has a position. So wherever your thumb is on the circle, you can read that and use it as a controller. So this is an example using your thumb position on the dot to control driving a robot. So when the blue dot is pressed, read the position, and if it's in the top quadrant, then go forward at that distance, so using that as the speed. So you've got a sort of -1 to 1 scale on your dot. And then when it's released, just stop. So you can have a really simple forward, back, left, right controller on your phone to remotely control a Raspberry Pi robot. There's another example that I wrote that uses the source values technique to clamp the values and drive the robot at specific speeds and specific points on the passing in values into the left and right speeds of the motors, which is more precise. And a friend of mine, Robbie, who's an Ubuntu developer, he has all these Z-Wave devices around his home. It's a protocol for connecting lots of devices together. So you have a server with code on it that controls all your devices around the home. There's nothing to do with Raspberry Pi as such. But what he did was he asked me about he wanted an API that would allow him to control devices like this and actually define the behavior the way that I've been talking about. And he's ended up implementing a sort of asyncio version of the source values technique. So he can actually declare in his how he wants things around his house to behave. So he's got things like in the bathroom the lights come on at a dimmed rate during nighttime and things like that. So the only difference there is that because he's using asyncio, is that the values are not being constantly passed. They're sent when they're changed. So it's a similar sort of technique, but asynchronously being sent that way. This is one of the examples of extending the ideas of the API. So the GPIO Zero source is on GitHub, and the documentation, extensive documentation, is on ReadTheDocs. I'll also be sprinting on this tomorrow if you want to come and have a look and want to come and join me. There's lots of suggestions and things that I'd like to look at implementing, so it'd be great to share that with some people. Now, you may have seen me speak the other day about piwheels on the Lightning Talks. So this is a Python package repository providing ARM platform wheels for Raspberry Pi. So when you pip install the library on Raspberry Pi, you get the you often have to build the C code from source, which takes a long time on the Raspberry Pi, because package maintainers were not able to provide ARM platform wheels for their packages. So what I do is automate all of those builds and keep up with any new releases. So we actually natively compile all the packages on PyPy on Raspberry Pi hardware and provide that as a repository at piwheels.org. So now on a Raspberry Pi, you can pip install things like OpenCV, NumPy, even TensorFlow, which is provided by Google. You pip install those things and you get them really fast. We're currently serving nearly 500,000 packages a month through that service, and it's all running on Raspberry Pi hardware. So even the web server that's serving those wheels is just a single Raspberry Pi. And again, the source for this is on GitHub if you want to take a look. We calculated recently that in the 10 months that this service has been running, it's saved a total of 23 years of build time. So it seems to have been a worthwhile project. And just to finish up, I want to tell you about a couple of programs. So Raspberry Jams are community events independently organized around the world. They tend to be family-friendly events, so a lot of the things that you see are sort of aimed at kids. These are, about learning to code, these kind of code clubs and things. Raspberry Jams are a similar kind of thing, but you often find people of all ages coming together to learn. So there's people who are programmers in their day jobs, people who are hobbyists, beginners, people who are more sort of into electronics and making and hacking. You'll find a lot of these around the UK and around the world. So they're a great way to get involved in if you want to learn about physical computing, and if you're here, you're interested in software, but you might not have done hardware stuff before. I certainly hadn't until the Raspberry Pi came around. And now it's got me kind of tinkering with things around the house. So it can be a really good way to pick up those kind of skills from other people, and also help younger people to learn to code. And CoderDojo are free coding clubs for young people. So we've got a big push in growing these around the UK at the moment. So this is for young people aged 7 to 17. But you can go along and volunteer as a mentor, or even start a dojo in your area. You can find more at CoderDojo.com. And again, this is a good way for you to learn new skills and pass on what you're learning to young people, which can be a really rewarding experience. There's some great projects that people make that they've made at home, and they can take it along to something like a jam or a dojo and demonstrate to young people what the advantage of learning to code is, and what they can make, and how they can make interesting things to change about their world. So I'll take any questions.
So I think we've probably got time for one or two questions. So just if you could wait for the mic.
Thanks for your talk. What ability does the library have to interface with LED boards?
Sorry, could you just bring it a little bit
what
closer?
ability does the library have to interface with LED boards? And have you got any recommendations, if it can interface with LED boards, which ones are useful?
Can you just explain what do you mean
so
by
like,
LED boards?
Okay, so the background is my friend and I built a train board running on a hat that could display 3 lines of text. And so we're looking to upgrade that from like a tiny display to a big one. But we had some challenges in terms of finding not just the software to interface with the hardware, but the hardware itself. So it'd be great to hear if it can interface with kind of big LED board hardware, and if so, which one you would recommend.
So there's lots of options for LEDs. We currently only support the basic GPIO LEDs, including RGB LEDs. Some of the more sophisticated LEDs like NeoPixels and APA 102 is what they're called. There's work in progress for supporting those. One of the things I could be looking at tomorrow. Really interested in being able to use these APIs to control those kind of LEDs, because the libraries out there, they do work, but they're not as friendly to work with. The APA ones, APA 102 I think they're called, or Dot Star, they're quite a good one that has quite good support generally, and that's probably what we'll add in first, or what we'll add in next.
Cool, thank you.
I'm afraid that's all we've got time for in this session, but obviously Ben's around today or tomorrow at the sprint. If you want to ask him more questions, please do come and find him. So please join me again in thanking Ben for an excellent presentation.